Hello everyone and good day and welcome to this online lesson on polygons. In this session, we will be exploring the exciting world of shapes and figures that have been a fundamental part of mathematics and geometry since ancient times. Throughout history, people have used polygons in art, architecture, and engineering to create a beautiful reflectional structures. From the pyramids of Egypt to the Eiffel Tower in Paris, polygons have played a crucial role in shaping our world. So, in this lesson, we will be discussing what polygons are, how to identify them, and what properties they possess. So, we will start with the basics of what makes a shape, a polygon, and then move on to more complex. I know you are excited, so let's get started. Oh, before that, let me introduce myself. I am Erno Ampati from BS Ed Math 3A, studying at Eastern Science State University. So, let's go. So now, my dear students, let's take the challenge. So, in this lesson, challenge yourself to attain the learning outcomes. First, illustrate polygon according to the number of sides and angles. And last is differentiate the convex and non-convex polygon. And before we begin our lesson on the introduction of polygons, let's warm up our brains with a fun crossword puzzle. This puzzle will help you to review some of the key terms and concepts related to polygons that we'll be discussing in today's video or today's lesson. So to complete the puzzle, you will need to use the clues provided to fill in the words horizontally and vertically in the grid. The words in the puzzles are related to polygons, so such as the number, the names of polygons, and so on. So don't worry, students, if you don't know all the answers right away, because as we'll be going over the if we're going over them together once, everyone has completed the puzzle. This free activity is a great way to get your brain working and to get you excited about learning more about polygons. So without further ado, let's begin. Number one, for a cross, it is a two-dimensional closed figure which has at least three straight sides, straight angles, and three vertices. What do you think the answer? Correct. It's polygon. Number two, for down, it is a polygon is blank if and only if a line containing its sides or its extended side does not cross the interior of polygon. Correct. So it's convex. Number three, they are the opposite of convex polygons. What is it? Correct. It is a concave polygon. Next is the prefix of eight-sided polygon. What's the name of eight-sided polygon? It starts with letter O. That's the clue. Yes, correct. It's octagon. So the prefix is octa. Very good. Now the number five is six-sided polygon. So what's the name of the six-sided polygon? Our only clue is X. It's X. The third letter is X. So correct. Hexagon. Now continue for down. Number six is the prefix of six. Oh, seven-sided polygon. What is it? The only clue is H. Correct. It's heptagon. The prefix of heptagon is hepta. Number 7, down. So, polygons that have more than 20 sides are called blank. What is it? Only clue is the first letter is N. Correct. It it's Engon. So number 8, for a cross prefix of five-sided polygon. So what's the name of five-sided polygon first? Correct. It's pentagon. So the prefix is penta. Very good. Second to the last, number 9, it is a cross, a figure which is formed by two rays or lines that shares a common endpoint. What is that? Correct. It is an angle. Very good. So, last one for a cross. So, number 10 is prefix of nine-sided polygon. So, what's the name of the nine-sided polygon? It starts with letter N. That's our only clue. Correct. Perfect. It is a nonagon. The prefix is nona. Great job, everyone! I hope you all enjoyed the crossword puzzle and found it to be a helpful review of some key terms and concepts related to polygons. Now that we have warmed up our brains and reviewed some important terms, we are ready to dive into our lesson into the introductions of polygons. I hope you are feeling excited and ready to learn more about these fascinating shapes. Remember, if you have any questions or need clarifications on anything throughout the lesson, don't hesitate to ask. We are all here to learn and grow together. Class, as we just learned, a polygon is a two-dimensional closed figure that has at least three straight sides, three angles, and three vertices. But where does the term polygon comes from? And why is it important to understand its meaning? So the word polygon comes from two Greek words, poly, which means many, and gon, which means angles. So when we put these two words together, we get many angles. This is an important term to understand when studying geometry because polygons are defined by their angles and sides. So by understanding the meaning of the term polygon, we can better understand the significance of these two-dimensional figures and how they relate to other concepts in mathematical and the real world. So let's keep this in mind as we move forward in our study on polygons. Now here's the examples of the polygons. So we have here the table that consists number of sides in the first row. In the second row is we have name of polygons, and the last row is the figures. As you notice, the number of sides is 3. The names of that polygon is triangle. As you can see in the triangle, it has a 3 side. Now, also in quadrilateral, it has a 4 side. And also count in the pentagon, we have the 5 sides count in the figures. So we have 1, 2, 3, 4, and 5 sides. It's the same with hexagon with 6 sides. It's called hexagon. And we have the 7 sides. It's called heptagon. Heptagon because yes, it is a number of sides, 7. It's called heptagon. Now we have 8 sides. It's called octagon because it has the figure as you notice is has eight sides. Also the same with nine sides, it's called nonagon. Also in 10 sides we have decagon. And we have 11 sides, it's called undecagon. When we see a pentagon, oh no, we see the polygon with 11 sides, you can now determine or identify what kind of polygon is that, correct? If the polygon, if it has a more than 12 or more than 12 sides, it's called angon. Oh, so we have here another example. So as you notice, this shapes is a non-polygons. Why? Why is it not a polygon? Because this shape did not meet the characteristics of a certain polygon. So what are those? So a polygon, it has a three angles or more angles, and it will have a vertices and also a closed figure. As you can see, these shapes are curved. This is not a straight line. It don't have a lines. As you can see, the last figure is has a line, but it has also a curve. So that is a big X. So it's not a polygon. Next is the types of polygons based on their angle. Well, a polygon can also be classified based on their angles formed by the adjacent sides of a polygon. The measure of the angle may be less than 180 degree or more than 180 degree. So based on these polygons are classified as convex polygons and concave polygons. So the interior angles of an n-sided polygon are given by the formula n minus 2 multiplied by 180 degrees over n. So this is the convex polygons and the concave polygons. The convex is these polygons have the measure of their interior angles to be always less than 180 degree. So it means when the interior angles of a polygon is less than 180 degree, it's called a convex polygon. However, we have here the concave polygons, which is the opposite of this convex polygons, which means a defined as a polygon in which one or more interior angles are more than 180 degrees. So if is the interior angle of a polygon of a certain polygon is more than 180 degrees, we can call that a concave polygon. So for more understanding of this topic, so let's have a example. Now here's the example of convex polygons. So this polygons is called a hexagon because it is a six-sided polygon, and it's considered convex polygon because it meets the definition of the convex. So to understand why hexagon is a convex, let's consider its angles. A hexagon has six interior angles, and each angle measures less than 180 degrees. So the sum of the interior angles of a hexagon is 720 degrees, which means that each interior angle measures 120 degrees. It means it is less than 120 degrees. So, so let's take a look. Let's take a look at the vertices of a hexagon. A vertex is a point where two line segments meet. So, in a convex polygon, all the vertices point outward. If we draw a hexagon and connect its vertices with line segments, we can see that all the vertices point outward. So therefore, since a hexagon has all interior angles less than 180 degrees and all its vertices pointing outward, it meets the definition of a convex polygon. So here's the example of concave polygon. So this is a pentagon which is a has a five-sided polygon. As you can see, one of the vertices of this pentagon is pointing inward towards the interior of the polygon. So this is an example of concave polygon because it has at least one interior angle that measures more than 180 degrees. So in this case, the angle formed at the concave vertex is greater than 180 degrees, which makes the pentagon concave. And another way to see that this pentagon is concave is to imagine drawing a line segment between any 2 points within the polygon. If we do that, we can see that the line segment intersects the boundary of the polygon more than twice, which confirms that this is indeed a concave polygon. So next is the types of polygons based on the measurement of sides and angles. We have here a regular polygon and a irregular polygon. A polygon that has all equal sides or the same length and angles is called a regular polygon. In other words, regular polygons are equilateral and equiangular polygon. So it means it has a same length of sides and it has a polygon it has all congruent. And also in irregular polygon, an irregular polygon is a figure that has unequal sides and unequal angles. So literally is this is a opposite of a regular polygon. So let's take a look for an example. So this is the example. So this is a four-sided polygon, which is a called quadrilateral. So as you can see, the angles are equal, and also the four sides are equal. So this is literally a regular polygon. So let's have a more example of it. So as you can see, we have 8 examples, 8 different polygons, which has a different of which has a all are equal of its sides and also equal on its angle. So let's take a look with a regular heptagon. A heptagon we have 7 sides. So as you can see, the sides of this heptagon are equal, and also the angles. So it's the same with the regular hexagon. A hexagon we have a 6 sides that the sides are all equal, also the angles. So let's move on to a irregular polygon. So this is an irregular polygon. This is a quadrilateral polygon which has a 4 sides. As you notice that this polygon are unequal sides and have equal angles. So it means this is an irregular polygon. So let's take a look for another example. So this is another examples of a regular polygon. So we have here the different polygons, the different sides. So we have here the heptagon, irregular pentagon, hexagon, also a decagon, and others. As you notice, this is a their sides are unequal, so that's what makes them a irregular polygon. So that brings us to the end of our discussion on the introduction to polygons. We've learned that polygons are closed figures made up of straight sides, and we explored some of the common types of polygons based on the measurement of their sides and angles. Remember that regular polygons have all sides and angles equal, while irregular polygons have sides and angles of different lengths and measures. Also, convex polygons have all interior angles less than 180 degrees, while concave polygons have at least one interior angle that's greater than 180 degrees. And understanding the properties of polygons is essential for various fields, including the architecture, engineering, and design. It is also important for developing critical thinking and problem solving skills. So, as we conclude, I encourage you to continue exploring the fascinating world of polygons and geometry and to practice drawing and identifying different types of polygons to help you develop a deeper understanding of their properties and applications. By the way, thank you for joining me in this journey, and I wish you all the best in your future endeavors.